Hey Flight Simmers, welcome to episode number 2 for the parking brake for my Airbus A320 cockpit. In episode number 1 we did the 3D design in Autodesk Fusion, and today we will have a look on the parameters for printing. We will do the assembly and finally connect it to the flight sim. As usual, all the files for printing, the configuration data for Mobiflight are available for all my supporters on Patreon, so follow the link in the description. But now, with no further ado, let's go into BambuStudio and have a look on the printer settings. Well, in BambuStudio, there's nothing really special about printing all the parts. Let's start with the bottom, the cage and the latches or the locks for the top panel. There's nothing really special about it. It's completely stock settings, 0.2 millimeters, the standard setting in BambuStudio for the bottom and the cage. For the locks, as usual, I'm adding a brim to the side just to have a little bit more contact area to the build plate. For this, go to Objects, select all the locks, and in there, under Others, select the brim type to outer brim only. But the rest are still the stock settings. Back to the top component. In there, of course, I have to change the filament types to the corresponding colors, and as usual I'm adding a height range modifier from 0.2 to 0.6 millimeters. In this range I will set the quality, the line width, to 0.26 millimeters for all the values in here, so when I'm slicing the part all the labels are printed with 0.26 millimeter width, and the rest of the panel with a stock setting. The first layer is set to the Hilbert curve under the strength tab, bottom surface pattern, the Hilbert curve, just a nice pattern. It looks not printed like the diagonal lines, so it looks much better. That's the top component. Back to prepare. The handle, just two colors, white and black. And in here I have a height range modifier as well from 0 to 0.4. Just for a finer line width for the label. And on the last build plate there are the gears and the lock. And for these three I changed the quality, every value to 0.26, so especially the gears, the teeth are printed in a much higher quality. So here you can see the first layer, it's still the stock setting, and from the second layer on it's a finer line width. And that's about it of printing all the parts. Just send it to the printer and we are ready for the assembly. Okay, the assembly is actually really pretty simple. What do we need? Of course, the printed parts like the panel, this little cage, the two gears, the little lock, the handle, and then a spring. This is a 10mm spring. The length is about 30mm. I got this from this package I ordered on Amazon. In there are several types of springs. I use them a lot, so just go on Amazon and search for a spring assortment. 2 screws and 2 self-locking nuts. It's size M4 and the length, in my case it's M4 by 12, but it doesn't matter because it can be even longer, because the bolt will go right into the hole of the cage and the hole goes all the way through until the top. So the length actually doesn't matter. And then for connecting all the pieces together, we need a piece of 6mm tube. This is the same type of tube I'm using for the large center overhead panel parts to connect the segments. It's 6mm in diameter and 4 on the inside. I got these from the local hardware store. There you can get it in 1 meter or 2 meter pieces. And if you haven't bought it already, and if you want to build the speed brake unit as well, I would recommend to get an 8mm tube as well. It's 8mm, the outer diameter, and 6 on the inside. And the 6mm tube fits in there, and I'm using it in the assembly of the speed brake and the flaps as well. So if you want to build these units too, you should consider to get it straight away, the 8mm tube as well. And what I also need is a 4mm. It's not a tube, it's just a round bar in 4mm. And from this tube I need a segment of approximately 15mm, one segment of 11 and another of 21mm. The length of the tube, a 6mm tube, is approximately 90mm. And of the 6mm tube we need a shorter tube as well, and it has 18mm. Okay, these are the items we need for the assembly. I already glued the little latches to the top component and I mounted the backlight and the potentiometer already to the panel. I did a whole video on the backlight and on the potentiometer, so I will skip it in this video. If you have any questions about it, I would recommend to watch these 2 videos, the backlight and the potentiometer. So I want to keep this video really short. So what's left to do is to mount the gear and the lever to the panel. And I will start with the little lock. The hole in the middle, it's designed with 6mm. If it's too narrow and the tube is not fitting in there, you can just open it up with a drill bit, 6mm, and then the tube will fit. Then I put it into the bottom panel mount the top component. And now the depth of the hole in the handle is 18 millimeters. Now set the height of the tube to 18 millimeters or less. Now it's 17.5. That's just perfect. And now the first thing I will do is to connect the lock to the tube. It's already on the right height of the tube. And now I will use the hole on the side to drill the hole into the tube. For this I'm using a 4 millimeter drill bit. It fits right into this hole on the side. And now with a little bit of pressure from above on the tube, I'm drilling the hole from the side. Now I'm using the 15 millimeter piece of the 4 millimeter bar and feed it right into the lock. Now it's in place and the lock can be moved on the bar. Put it back into the assembly. Now let's go on with the back side. I assembled the top component so the bar doesn't fall out. Okay, then the next is the spring on the tube. Then we need the large gear, and with this little pocket, this is a pocket where the spring can react into when we pull up the handle. And with a pocket downwards, just like this, onto the tube. And now with the spring engaged, you can already check the functionality. Have to push it upwards, then the 90 degrees twist, and the spring will pull it back downwards. It already works really well. For the height of the gear, just mount the cage temporarily and push the gear downwards until the cage is in place in the pockets of the bottom component. And now there's a little bit of space between the cage and the gear. Alright, it's a small gear. I already inserted the small piece of 6mm tube on the side with a full cylinder, not the gear, and with the other hole just mount it onto the potentiometer like this. And now for the alignment of the large gear, just turn the potentiometer all the way to the left, then turn the large gear until the first tooth is engaging the small gear. And this should be the first position. Now when I pull up or pull down the handle and turn it, okay, I'm feeling a little bit of resistance of the lock on the inside, so maybe it's not enough travel. Okay, now there is no resistance on the inside. And now I found the right location of the large gear. Let's put the cage back into position. Check the height of the large gear again. There should be a little bit of space between the gear and the cage. Okay, and now we can mount the cage. For this, simply insert the self-locking nut from the side. And feed the screw from the inside through the hole. Let's check it again. Still works perfectly. So we have to drill another hole into the large gear. For this I put it in the direction that the hole is pointing to the side. And then, like I did with the lock on the inside, I'm using the 4mm drill bit and drill the hole from the side. And here I'm using the 11mm piece of the 4mm. Feed it in there. Okay. Now this one is locked too. And all what's left is to put on the handle. For this I'm closing the lid. And set it to the parking brake on position. And in this position, I'm drilling another hole from the side over there. And now the last piece is the 21mm piece. And with this piece I'm securing the handle. Okay, and now the parking brake is fully assembled. All what's left to do is to connect it to the SIM. So let's go into Mobiflight and do the connection to the flight sim. Okay, the connection to the SIM is actually pretty simple. So I connected the parking brake, 3 wires, to my expansion board. So plus 5 volts and ground from this JST-XH connector. And then the analog pin is connected to analog input 1. That's all you have to do in order to connect it to the hardware. And then for the configuration in Mobiflight, just go to the Mobiflight modules. In there, I'm using my Arduino Mega. And add a device, an analog input. Pin setting is A1 and name it parking brake. On the input configs, I'm adding a new row, name it parking brake. Go to the edit page, select the module and the device. And the on change action type, I just crashed my airplane because the parking brake was released. Okay, so it rushed down the runway and crashed into something very nice. Back to simulation. There is my parking brake. Parking brake is on in the sim, but not on my panel. So let's connect it. The action type on the on change page is not a direct Microsoft Flight Simulator value. I will store it in a Mobiflight variable. Name it parking brake. And very important, the value, change it from the $ to the @ symbol. So the value of my analog input is stored into this variable with the name parking brake. Hit OK. And on the output configs, I'm using the variable I just assigned to trigger the parking brake. Go to the edit page, and in here select the variable type, to Mobiflight variable, select the parking brake, and it should already display the value type. So in the debug window, when I'm changing, yes, it's already working. So when I move the handle, you can see the resistance of the potentiometer changes from 155 to 1023. Okay. And now let's map it into the value. So on the display type, I want to trigger an input action on change because it's an analog input. And in there, just select Microsoft Flight Simulator, search for park, 81 matches found, and in here A32NX park brake lever toggle. It's my Airbus A320 from fly-by-wire, so this is the right input. And because this lever input or this toggle needs a value between 1 and 0, or 1 or 0, I have to map the analog input into these two states. And for this, I'm adding a modifier on the modify page and add interpolation modifier. Two values. Input value of 0 maps to 0. Then let's say right in the middle from 500. Every value between 0 and 500 will be mapped to 0. And from 501 to 1024, it maps to 1. Hit OK. Now you can see the parking brake just flips. So it's released in the sim. The output value in Mobiflight is 0. When I turn on the parking brake, now it's on, off. So the parking brake is connected to the sim. That's how easy it is with Mobiflight. All right, another piece for our large puzzle is finished and ready to use. Today we finalized the parking brake. The next piece of the puzzle will be the speed brake. So in the next video we will focus on the 3D design for the speed brake and how to manage larger assemblies in Autodesk Fusion. So I'm really looking forward to see you in the next video. If you haven't done it already, please subscribe and hit the bell. If you find this video useful, please give it a like. But for now, I hope to see you in the next video.